Hi everyone, welcome to our first lesson of Unit 4. So in your packet, go ahead and find the one that has the front page, How Good is Your Teacher at Free Throws? So I'm going to claim that I am an 80% free throw shooter. I'm pretty good. So I have a lot of skills on the basketball court. Now, how many free throws do you think I need to shoot before you're convinced that I'm an 80% free throw shooter like I say? So you obviously can't watch me shoot free throws right now, but I have done this so many times that we've recorded my skills in an applet. So you're going to go to bit.ly/51 free throws. You can use the applet to watch me shoot free throws. Please follow the directions on here. You're going to uncheck show true probability and then change the shots to 1 and click shoot. And once you do that, it'll shoot the ball. I'll shoot the ball for you. And you'll record whether I make or miss. Just use a check for a make or an X for a miss. And then proportion of makes. So this would be out of 1, out of 2, out of 3, out of 4, or you can do it as a percent. When you get to the 10th right here, you'll want to do 5 in a row and just record the last shot for the 10th, 15th, 20th, 20th, and this first top row. So you can try to make that faster, or you can just click the button 5 or 10 times, depending on which one you need to get to. And if you feel like you figured it out before you get to 80, then feel free to stop and start doing number 2. Then you'll sketch the graph displaying the proportion, see how you can make your guess more accurate, and then at the end you can check show true probability to see if you were right and if I was right at 80%. So pause the video, do the activity. It should only take a couple of minutes, and then come back and we'll go over some answers. Okay, so the main thing to remember is that these are sample results, not your results. So everyone's had different shots being taken, different probabilities, and these are the results that I got when I did the activity. They're different than yours. So you don't need to be copying down this page. I'm going to write varies in my blue. But when I did it, I started off really strong. I made my first shot. I was feeling good about it. And then it went all downhill from there. So in the end, it looks like if you look at my percents, I was at 100, then 50, 33, 25, 20, 40, 47, and I ended up around 27, 26. And so I felt like I was about 25% of a free throw shooter. And then here's my graph. I was claiming 80. I started off higher than that at 100, and then I went down immediately to 50 on the next shot. And so then I never even made it close to 80. So according to mine, I was a really bad free throw shooter, which might be more accurate. So you can sketch that graph. And then how could I make my guess more accurate? Just keep shooting free throws. The more you shoot, the better estimate it'll be. And then when I checked show true probability, I got 30%. So this would vary for yours, and this number would vary for each person. And so that means in the long run, I expect to make about 30% of free throws attempted, and that will vary, whatever that number is. And so don't worry if you got different things than that. Now, let's take out a different color pen and debrief some of this. First, this is just an introduction to probability. What I want you guys to realize is that, when I shot that first shot, I made it. That does not mean I'm a 100% free throw shooter. And so one thing I want us to think about here is when we're looking at 1 to 2 to 3, is we're going to write probability is unpredictable in the short run. And so that is our first thing to keep in mind. Probability is unpredictable in the short run. And then if I want to make a good estimate, then I can do it more and more and more. So the answer to number 4 is shoot more free throws. That's an example of the law of large numbers. It says if I do this over and over and over, then I'll get closer and closer and closer to the true proportion. And when you show true probability, that is what we call the parameter. And in this case, it was the true proportion of free throws made, and it represents the probability. In this case, each of the shots in the table would be called statistics because they came from samples. And so probability is the long run estimate of proportions. And so then the last thing I want to do is talk about the interpret right here. We pretty much always say the same thing. You want to always start with in the long run. And then we expect Miss Pendleton to make about, this is our context. This is where we put the probability. And then we have context there and there. So I'll label all that for you. So, and I'll just add the word interpretation with an arrow so you know how to do it in the future. Now we're also going to do this on the important ideas box. So just flip your paper over and we're going to fill in the important ideas box right here. So I have a couple of things. I have a definition, probability, long run relative frequency. Remember, relative frequency is a percent or a proportion. And so that's what it is. It's always between 0 and 1. It's unpredictable in the short term, but we can predict it in the long term, and that deals with the law of large numbers. So go ahead and pause this, get all this written down, and then you can unpause and or you can move on to the check your understanding, then unpause for the answers. And then a couple quick things before you move on. 0 would mean never. 1 means always. So those are some things that you should probably know from previous math classes, but I want to make sure you have it written down too. Pause, try to check your understanding, unpause, and come back to check your answers. All right, so here we have the interpret. You want to make a flashcard for that so that you can get it right every time. And then here we have these probabilities. Remember, it's a percent. These are proportions, so it's the proportion of time you expect something to occur. Always is 100% of the time, never 0% of the time. We have 0.001 for very unlikely, once in a while. More often than not, it's bigger than 50%, so 0.6. Almost every time, 99%, and less often than not, 0.3. These are just examples. 51% is also more often than not. 49% is also less often than not. So we have just some examples. And then this last one, a husband and wife decide to have children until they have at least one child of each sex. The couple has had 7 girls in a row, and their doctor assures them that they're more likely to have a boy next. Why is the doctor wrong? So each time they have a child, they're going to have a 50-50 chance of getting a girl or not. And so that is still the same, even though they've already had 7 girls. This just happened to a friend of mine where she has 4 boys, and she was pregnant again. She made everyone guess what the next one would be, and I guessed boy because I knew it's unpredictable, 50-50 chance, and I was actually right. So there's a lot of interesting stuff out there about that, and at the end of the day, though, it's about 50-50. All right, you guys have a great day. Check Canvas for what to do next, and we'll see you next class.